Good evening. Apologies I can't be with you physically for the talk tonight. I'm based in the UK and the government has brought in a preposterous 2-week quarantine if we visit the Czech Republic. So instead I'm going to be presenting in this 3D world and we'll be whizzing around a model showing images and films. My talk is going to attempt to weave together some separate threads of research I've been working on based around algorithms, abstraction and its relationship with the contemporary production of architecture. It's a work in progress, it might seem a bit disjointed, but I hope leads on from Maris's talk and ties in with the liquid aspects of real estate critiqued in Oskar's work. My focus will be post-2008 and in particular the last 5 years. I will give some brief background before going into 2 examples of how architectural production, and by architectural production I mean this globalized web that typically goes into the realization of a building, including areas like financial capital, bureaucracy, regulations, material and immaterial labor, resource extraction, and so on. Areas within this that kind of look to be further affected through algorithmic extractions that are unfolding at the moment. So to give some context, towards the end of 2018, an underreported yet significant event occurred. Tech companies, including Facebook, Amazon, and Google, stopped being distinct groups on the stock market. The rationale behind this was twofold. The first was these companies had strayed so far from their original digital services into traditional sectors they no longer warranted special treatment. But more importantly, traditional sectors have had to equally embrace algorithmic technologies to stay competitive. The result of this was these technologies had in effect become generalized, ubiquitous, and underpinning the function of our economies. This has led commentators to suggest we are living within an epoch of techno-scientific capitalism, surveillance capitalism, global hypercapitalism, the list goes on. Philosopher Bernard Stiegler argues commodification today includes knowledge itself, where big data disintegrates knowledge into information through applied mathematical and correlational algorithms. Stiegler claims modernity today is defined through instruments of calculation, instruments of statistics, measurement, simulation, modeling, observation, production, and metrics of the quantified self. In these processes, even social dynamics can be calculated and formalized through data and treatment algorithms. So it's quantification at an incredible scale. This for Stiegler is automation at an incredible pace where algorithms can work at speeds 4 million times faster than the individual nervous system, producing results that outstrip our capacities for reason. The modernity Stiegler's tracing here is ruled by abstraction and ties in with ideas from Frankfurt School theorist Alfredson Rettel, whose idea of real abstraction describes actions reduced to a bare-bone reality, abstract time and space, abstract matter, quantity of mathematical abstraction, and abstract motions. These abstractions for Son Rettel can reductively describe every natural event in the world where anything observable fits within the same kind of framework. Architectural production does not escape these wider developments, and the use of algorithms can be seen merely as an acceleration of existing trends that have been happening over the last 30 years. As I'll try to show, they serve to further abstract space and give an output to a very narrow set of questions based around some form of optimization. This is abundantly clear in the emergent industry of prop tech, a really horrible name, and the use of real estate algorithms at the scale of the city. Prop tech merges 2 main vectors of abstraction, monetary and technological, and then subsequently gives an optimized output on real estate investment decisions. To go back though, real estate is an industry built on abstraction. The map shown here is from 1834 of early Chicago by Joshua Hathaway Jr. Aimed at real estate developers, the grid shows 32 meter square plots. And as you can see, these plots are completely abstracted from any natural topography other than the river, which is seen as an industrial asset in itself. Jumping forward back to today this abstraction takes on new forms with the globalized relationship of real estate and finance that's been kind of developing over the last 30-40 years. Financial actors serve to liquefy physical assets, integrate them into the financial market. space in this instant becomes another asset class, such as shares or bonds. So they kind of aim to bring physical space into the liquid world of finance, pretty much. There's a language used to describe this, and it consists of easily understandable numbers. Quantification techniques are used to translate qualitative information into quantitative objectified truths. An example of this is mathematical techniques developed by David Geltner in the 90s estimated real estate volatility in the same way and in the same language as used to describe shares. Another quantification technique includes property indexes. MSCI property indexes use a dizzying array of mathematical formula to create these graphs for property investors. This includes things like market rental growth, yield measures, internal rate of returns, asset value growth, relative returns, the list goes on. The results of this are graphs like the Global Annual Property Index or Investment Property Data Bank, which effectively abstract space at the national level to show total market sizes. In these instances, the Czech Republic becomes defined by an average cost per metre square for housing, the number of properties in the country, the total value of all real estate in the country. Using these abstractions, property in the Czech Republic has one of the highest rates of return in Europe, which explains maybe why it then becomes attractive to investors or real estate trusts. So within these existing real estate process I've just described, PropTech is an emerging sector that comprises large and smaller startups that use algorithmic technologies to find fresh areas of commodification. The sector works in three broad areas. The first is the operation and management of real estate, so things like digital landlords. The second is real estate finance, so kind of technology that helps companies trade in real estate, including things like shares, funds, and debts. And the third is real estate usage, so the use of the kind of final use of the space. Airbnb, a company that kind of count in that regard. On the financial side of PropTech, a good example is Skyline AI, who have set themselves the task of introducing the world of commercial real estate to high-frequency trading. In Skyline's own words, they want investment to become less intuitive and more data-driven and scientific, so that, I quote, it's comparable with what we're used to from the stock market, where robotic trading is currently responsible for about 70 to 80% of trades, end quote. PropTech companies effectively aggregate existing financial abstractions and link it with governmental data, which is all now available online. A typical example of this is Geophy, who take data from 10,000 sources. This includes things like REIT filings, information from REIT websites, appraisal reports, and things from equity investors. This is all merged with basic data on the space itself, so the size of the property, occupancy rates, and things like transaction prices. More mathematical statistics are added to the algorithm, but this time the government data, so things on the national level and local level, so employment, market information, education, crime and housing statistics. Yeah, the novelty of these kind of PropTech companies working in the financial part comes from their attempts to effectively quantify experiential aspects or how we experience a local area, particularly those who are going through a process of gentrification. So they effectively try to calculate in some way the atmosphere of a place, something that we might consider very kind of unique, but something that can apparently be brought into some kind of a mathematical equation. Geophy, for example, aggregates data such as school ratings, transport links, consumption habits, are also measured by social media check-ins, amenities like coffee shops, the presence of certain retailers, events that are happening in an area, and social media trends. So as I say, these can all be quantified and effectively measured to gauge this kind of atmosphere of an area. Similarly, Skyline AI use a Google Maps-based application to create an abstraction of a property in relation to its urban environment. They map kind of points of interest, such as schools and parks, restaurants, and the general kind of infrastructure. As a bit of a side note here, I also thought it was quite shocking to note that GFA are now looking to add climate change data to their kind of platform, to then help kind of REIT investment decisions. To do this, they merge flood risk data and data from the UN panel on climate change. Their aim is to show, and I quote, the combined effects of these changes on agriculture, mortality, energy, low-risk labour, high-risk labour, coastal damage, and property, and then to then see how that might affect REIT decisions in where they're investing. All of this comes together in a process of optimization at the end, where the output of all this is where these quantifiable abstractions are brought together through an algorithm to give a decision on whether a property is worth investing in. For Skyline AI, these abstractions are visualized and mediated through a proprietary digital interface with over 400,000 properties in the US mapped using 10,000 individual bits of data per property, similar to GFE. This is explored interactively, much like a video game, through parameters such as rent-to-income ratio, rent-to-occupancy, or valuations above $50 million. The algorithmic output is a 15-year prediction for each property, instantly showing the cash flow projection with a corresponding go, no-go decision on whether to invest. Using this automated technology, Skyline AI claimed a year ago the first ever property acquisition took place. 2 apartment blocks in Philadelphia bought for $26 million, which they claimed were mismanaged and not generating enough profit. I think here there's also a kind of interesting crossover with other companies that are using these kind of location-based algorithms to make decisions on where to either invest in the location of their businesses. So WeWork claimed they were doing something very similar and had created their own platform to kind of do that, and they'd measure kind of the cultural capital of an area to do that, to where to locate their co-working offices. And similarly, kind of Amazon, Walmart also use location algorithms to choose where they put their warehouses. But just to kind of finish on these PropTech companies, I think it's just important to say that they're not necessarily something new, but they represent something that's kind of more systemic, calculable, and more of an accelerated model concerning the extraction of value from physical space that we've seen emerge over the last 30 years. Working at the scale of the building, a similar process of kind of reductive algorithmic extracting is at play, but this time more spatially in what has been dubbed generative design. Generative design looks to replace parametric design in the computational use of algorithms to design building forms, facades, and layouts. Parametric design is defined through giving individual parameters for a given project, and a computer effectively just spewing out 3D models based on these. The designer can tweak those individual parameters until they then find an appropriate design. Generative design looks to replace this, and it's kind of emerging at the moment, to semi-automate and optimize the design process itself, where an algorithm can generate designs and pick the best option based on a variety of inputs that define the design tasks. So the designer is defining the design task through inputs of data. The computer is then designing tons of options, and then the computer is then evaluating those options, which the designer then chooses the best one. Is how it apparently goes. Building performance such as circulation, occupancy, daylights, and other key features can also be simulated, predicted, and measured. So it's like highly performative. And there's a similar crossover here with, I think, some of these PropTech companies. So global corporations, including Foster's and partners, have developed their own in-house optimization software and claimed at the start of the year to have used generative design for a new headquarters for Alibaba in China. Similarly, Zaha Hadid architects, through their Analytics Insight unit, are developing their own in-house generative design tools. One instance they're using this is office design, where they can generate and evaluate options based on productivity, wellness, collaboration, and in effect creating thousands of options. So again, it's quantifying things that we might consider unquantifiable, like wellness, health. At the urban scale as well, the companies are also using generative design. So Google or Alphabet, with their sister company Sidewalk Labs, are using software, use the software for their urban planning of the now defunct Sidewalk Labs, which you can see in this film playing on the screen. But it's Autodesk that are aiming to make this technology mass available, so not in-house, but kind of available to any designer. Autodesk have been developing generative design tools for BIM, and in a similar vein to Skyline AI, Autodesk claims architectural design produces very little hard data, and as such, stakeholders have to rely on architects' design rhetoric. At the same time, Autodesk claim architects can't, I quote, quantifiably determine whether design objectives have been met. So generative design, as I mentioned, it can be used in the design of layouts, facades, building forms. But I'm just going to focus now just on the kind of layouts and the spatial planning. So to counter what has been termed, what they're calling it, generative design, it's historically actually gone by layout optimization. And layout optimization has a long history that originally emerged alongside the birth of factories, plants, warehouses, and other modern industrial production facilities. Architecturally speaking, designing optimal arrangements is effectively like a jigsaw. Here, designers use intuition and rules of thumb to solve problems of scale, adjacencies, and distances when planning a space. Layout optimization effectively tries to optimize this process, but it's a crazy thing to think. So, like, how before that even starts, before this even get to this point of even talking about kind of the optimization of space, it first needs to be kind of abstracted into a code that is recognizable by a computer. So there's a series of ways that can happen. So the development of this, of turning architectural space into a code, an abstracted code, goes back to the 60s, where plan representation largely mirrored developments that were happening in linguistic theory, mathematics, and structuralism, where researchers were looking to find an underlying structure, syntax, or grammar to architectural forms or spatial arrangements. So it's saying that beneath any kind of plan or layout of a building, there is some underlying grammar that kind of ties everything together, that you can read a plan like that and kind of uncover this hidden grammar. And the moment you start thinking about plans like that, the moment this idea of automation of that planning then becomes on the agenda. So to find this grammar of a given plan, researchers turn to topology, which is a branch of mathematics which deals with space as an abstraction, as a series of relationships, connections, and boundaries that work independent of the size or shape of the space. When you look at space in this way, it can be presented through graphs, bubble diagrams, dissections, and nodes, which can highlight kind of key features of a plan, like the relationship of spatial elements or adjacencies. Going back to Autodesk, who've used generative design on their office in Toronto, they set themselves a task of designing a highly functional space for employees, which apparently was supposed to somehow represent the different work styles and that people liked to work in. So to do this, Autodesk abstracts the existing space into topological cells, spines, C points, boundaries, and adjacencies. At varying stages, desks and amenity areas are added, and finally each team is allocated an area. Effectively, this framework that Autodesk creates allows different layout configurations to be made given different inputs. As such, Autodesk then use key metrics to analyze the plans generated to find optimal arrangements. The plan is abstracted into a layout graph where nodes represent desks and edges represent main circulation spaces. These graphs pretty much then allow plan configurations to be analysed and quantified in terms of adjacencies, circulation, views, daylight, and work style. So you can effectively rate the effectiveness of a floor plan, which is madness. These early extractions form the basis of layout optimization. And without these, the kind of automation, as I mentioned, would be impossible. So onto the kind of optimization process here within all this. So if a computer is creating floor plans, the varying options produced would, if exhausted, would run into the millions. So in the 60s, it would take a computer 3 days to generate 8 plans. But today, with the increase in computational power, this is no longer an issue. So rather than just have a computer like continuously spew out plans, computer scientists have addressed these kind of constraints by turning to genetic evolutionary processes. So what has become known as generative design is based on a process when competing solutions to a problem are ranked and selected across kind of generations. So the best design is kind of selected and then comes to the next stage. It takes kind of Darwinian ideals but uses them in a really extractive and kind of performative way. In Autodesk's case, they use a genetic algorithm to measure the performance of the plan according to these kind of given metrics. So Autodesk can thus analyze each design option and create a set of metrics to determine how each one performs in relation to the quantified design task. The designer can then generate multiple design options, choosing the best one. Here I think there's an interesting crossover with the Skyline AI or the Geophy kind of interfaces. But rather than this kind of go-no decision on whether to invest in a property, you're shown 10,000 generated plans, which are then kind of abstracted to points on a graph, which the designer then picks out that is best design for the task. The language used, I think, is also really similar to this prop tech industry, and I think it says a lot about this of generative design or layout optimization as an emerging kind of design trend. Okay, well, I hope all that makes sense. So in these examples, I've tried to show this evening new forms of abstraction emerging within contemporary architectural production. This is not in any way to be against abstraction. It's fundamental to how we think and reproduce social life, but it's against these particular forms of abstraction that keep the modern world going in its current apocalyptic death drive. These forms represent fresh areas of commodification within existing process of capital accumulation. I think that's obvious. As I've tried to show, this is taking on new levels where qualitative experience is given over to reductive quantified forms in which, and they can in no way really do justice to the thing they're extracting in the first place. For example, the experience of walking in the neighborhood. At the same time, I think it should be noted, just to kind of demystify this kind of thing of automation, that there's still huge human input and subjective human decisions within this kind of process. In generative design, it's the architect or computer scientist who decides where to draw spines and chooses this geometry system. And if you look at the final space itself, it's defined very much by these early decisions to choose a geometry system. Likewise, with real estate algorithms, the programmer chooses which data to include or exclude. An algorithm may suggest an otherwise bizarre direction for investment based on crunching thousands of bits of data, but the final decision in PropTech rests firmly on human input. But that said, there's a danger when these abstractions become physical objects in the real world, when the immaterial becomes material. This is where abstraction meets the everyday in the form of violent gentrification, displacing the powerless, smooth architectural surfaces defying hard contexts, and monitored bodies attempted to be made more productive. The literature I've shown tonight is bound by instances of objectivity, efficiency gains, performance, optimization, and rationality, but it would be wrong to claim any of these processes are truly rational. It's to this extent that rationalism here remains deeply irrational. Here the use of algorithms becomes almost a cult-like, a danger being the hysteria surrounding their use takes on their own mad dance, whether it works or whether they don't. Thank you.